Hello everyone. Today we will talk about introduction and history of photogrammetry. Photogrammetry has been derived from three Greek words. One, photos means light, gramma means something drawn or written using it, and metron means measure. This definition over the years has been enhanced to include interpretation as well as measurement with photographs. Now, traditional definition of photogrammetry: the art, science, and technology of obtaining reliable information about physical objects and environment through process of recording, measuring, and interpreting photographic images. Originally, photogrammetry was considered as the science of analyzing only photographs. But now it also includes analysis of other records as well, such as radiated acoustical energy patterns and magnetic phenomena. Till now, we understand that photogrammetry is the science and technology of obtaining spatial measurements and other geometrical reliable derived products from photographs. Here, word spatial means geographical location of any place or object. And photographs means not only the photographs. Cameras used for these are called imaging sensors. They can sense multispectral, infrared, thermal, and LIDAR information from environment. The input to photogrammetry is photographs, and the output is typically a map, a drawing, a measurement, or a 3D model of some real-world object or scene. Cameras used for photogrammetry are some are from Leica, from Microsoft. Those are like AD-S100 DMC3, Ultracam Osprey, and satellite InSat 3D, ReSat-1, Cartosat, OceanSat, etc. We can use now recent high-end digital cameras for photogrammetry. There are four formats. First one, highest quality DMC imagery that gives the best quality camera and post-processing available. Second, large format digital camera reduces mosaicing and take advantage of quicker post-processing, which will save your time and money. Third, medium format digital camera meets the higher accuracy, higher resolution requirements of engineering, mapping, and remote sensing tasks. Fourth, panchromatic black and white. This is most widely used type of emulsion for photogrammetric mapping. Now we will see how emulsion affects. Color photography is mainly used for interpretation purpose. Recently, color is increasingly being used for mapping applications. Infrared black and white, since infrared is less affected by haze, it is used in applications where weather conditions may not be as favorable as for mapping missions. False color. This is particularly useful for interpretation, mainly for analyzing vegetation, that is crop disease and water pollution. So basically, photogrammetry means measuring of features on photograph. That means data collected by these sensors without touching the object. Now we will look into brief history of photogrammetry. We know that the maps are created from ancient time. However, human being is always interested in inventing new methodologies to make process efficient, due to which scientists invented photogrammetry. The science of creating images and photographs dates back to the 14th century. Leonardo da Vinci is one of the earlier explorers of the science, developed the concept of perspective and projective geometry. In 1525, Albert Dürer used law of perspective and created an instrument that could be used to create a true perspective drawing. Frenchman Laussedat, referred as the father of photogrammetry, was the first person to use terrestrial photographs for topographic map compilation in 1849. The actual relationship between projective geometry and photogrammetry was first developed by Udo Haupt in Germany in 1883. Since then, the science of photogrammetry went through 4 development cycles. First was plane table photogrammetry from 1850 to 1900. Second was analog photogrammetry from about 1900 to 1960. Third was analytical photogrammetry from about 1960 to present. And last one, digital photogrammetry, is just now beginning a presence in the photogrammetric industry. Now, laser scanners and digital images are making a huge impact on the profession of photogrammetry. Plane table photogrammetry is an extension of the conventional plane table surveying. Each exposure station was determined by resection and plotted on the plane table. The exposed photos were oriented on the plane table and the directions of the different objects were transferred on the map sheets. Analog instruments are based on the concept of stereometric vision. Two photos are relatively oriented to produce a 3D model where details and contours are drawn. Alternatively, the 3D model is realized through projection of the two relatively oriented images. Analytical instruments, that is, analytical plotters, are based on the digitization of a homologous coordinates on two photographs identified by stereoscopic vision. Computer software produces three-dimensional coordinates of the point which are used for detail plotting and contour drawing in topographic maps. Now we will see basic principles of photogrammetry. Photogrammetry analysis procedures can range from obtaining approximate distances, areas and elevations using hard copy photographic products with unsophisticated equipment. Geometric concepts to generating precise digital elevation models, that is DEMs, orthophotos and thematic GIS data. Digital photogrammetry is changing rapidly and forms the basis for most current photogrammetric operations. However, the same basic geometry principles apply to traditional hard copy and soft copy procedures. Here, the hard copy means analog data and soft copy means digital data. Mapping from aerial photographs can take on numerous forms and can employ either hard copy or soft copy approaches. Traditionally, topographic maps have been produced from hard copy stereo pairs in a stereo plotter device. A stereo plotter is designed to transfer map information without distortions from stereo photographs. A similar device can be used to transfer image information with distortion removed in the form of an orthophoto. Orthophotos combine the geometric utility of a map with extra real-world image information provided by a photograph. The process of creating an orthophoto depends on the existence of a reliable DEM for the area being mapped. A digital photogrammetric workstation generally provides the integrated functionality for such tasks as generating DEMs, digital orthophotos, perspective view and fly-through simulation, as well as the extraction of spatially referenced GIS data in 2 or 3 dimensions. If you want to measure the size of an object like length, width and height of a feature, say house, then normally we will carry out directly at the object. Now imagine that the feature doesn't exist anymore, that is destroyed or modified. But with old photo existence, and if we know the scale of the photo, it is possible to get the desired data. In olden days, when there was no technology, we used to work with surveying to obtain ground reality, to do any kind of developments like irrigation, construction, mining work, water preservation, forestry, etc. The surveying process used to take so many years, but With photogrammetry technology, we can complete the work more faster, accurate, and with less amount of time and less risk. So this was all about the introduction and history of photogrammetry. Thanks a lot for watching this video.